Good day and welcome to our basic calculus class. In this video, you will be learning limits of functions. In order for us to better illustrate clearly what is this limits of functions is all about, let us have this idea here. Let us have this example. Let's say we have a parabolic shaped road, and then we have the billboard on the center, and then there are two cars. Let's say, for example, you are the one who is riding this car, and then you cannot see clearly the writings on the billboard because, of course, you are far. Say, for example, you are somewhere here. And the only way that you can see clearly the writings on the billboard is to move more closer to, or you're going to approach closer to the billboard. The same also with the other person riding on this car. This is an example of limits. You have the limitation. You can stop here so that you can read the billboard. And then once you're going to pass by the billboard, then you cannot longer see the writings on the billboard that is only on this certain part of that road unless you turn your head at the back. Okay, but here in the function, in the limits or in functions, the limitation is that it cannot pass by to it cannot pass by the billboard or this limit here. Once you have the limit here, you cannot pass on this side. You can only have this side up to here. This is the dead end here. The same also here. If you are in this part of the function, then you only have this certain side, and then there is a stop here. And then both values of x are approaching at that certain limit. They are meeting in between of that certain c or certain value. Okay, the same also in life. Let us try to connect it in our life. So everyone has their own limitations, and by knowing your own limits, it will help you it will help you to understand more the things that you are favorable to have, or the things that you have and the things that you cannot have. Okay, with this example here, if you're only limited to have this certain skill in your life in this certain limit here, you must just see your strengths here. Do not pass here because maybe you know that you really cannot have that one. It is good that you know your limitations as well. Okay, so much that one. Let us now try to learn more what is really this limits. Okay, so the limit of a function is the value it approaches as the value of x approaches a certain value. As x approaches a, the limit of x approaches L. Okay, so let us try to understand the meaning of this limits. Okay, in our lesson in this video. Let us have first the learning competencies. So at the end of this lesson, you will be able to illustrate the limit of function using table of values and graph of the function, and distinguish between the limit of a function and the f of c, or let's say the function. Okay, so when you are encountering functions, this is how it is being written. This is limit of a function as x approaches to c is equal to the answer. Okay, so again, you're going to read this as limit of a function as x is approaching to c. Okay, and take note that it is not the same as evaluating a function, wherein, for example, you have the value of c here, and then you're just going to simply substitute here in the value of x that is in the function. That is not the same. Okay, for example, you're going to write the function of this expression here written in words. Okay, so expressed in mathematical symbol. Yeah, limit of the function x plus 3 as x approaches 2 is equivalent to 5. So limit, just write here lim, and then next to it is the function x plus 3. And then as x approaches to 2 is under the lim word. X approaches to 2 with the arrow. And then this is now the answer, which is 5. Okay, again, you are going to read this as limit of x plus 3 as x is approaching to 2 is equal to 5. That is how you are going to read that limit. Now, let us try to illustrate the limits using graphs and tables so that you will really know what is this limits all about. Okay, so find the limit of the function f of x is equal to x plus 4 as x approaches to 2. So if you're going to write it in a mathematical symbol, you will have limit of x plus 4 as x approaches to 2 is equal to the answer that we are looking for. Ayan. So we are looking for the answer now. How to find the limit of this function x plus 4 with 2 as our c. So first, we're going to construct a linear graph here in which 2 is the center, or what we call the c. Okay, this is now the c. So we need to assign numbers that are to the left, or let's say from the left of 2, which is our c, and from the right of 2, which is our c, again our 2. So we have x is less than 2, of course, because it is to the left side, and then x is greater than 2 because from the right side. So we are going to assign any number that you can have, but it would be better if you are going to have a closer number. So let us start from 1.980, 1.985, 1.990 up to 1.99. You can have 5 intervals. You can use that one. And then as long as the last number is very close to 2. Okay? And the same also here. Since this is from the right, of course, this is greater than 2. So we are going to have 2.025, 2.020, and then it is becoming more closer to 2. It is almost to 2.001 thousandths. Okay, and then let us have the tabular form. So this is x is less than 2 and then f of x. What are we going to do with this? We are going to list all the assigned numbers that you assigned here. The 1.980, 1.985. Let us start from here because again it is approaching the C, which is on the center. So 1.980, 1.985, 1.990, 1.995, 1.999. What are we going to do with these values? We are going to substitute it in our function, which is x plus 4, so that we can have these values. We can find the value of our limits. So we have x plus 4, so substitute using evaluation of functions. 1.980, substitute in every x that you can see in the function. Since we have 1x, so we are going to have 1.980. This becomes x becomes 1.980 plus 4, that is 5.980. The same process you're going to do here, 1.985 plus 4, that is 5.985, and so on. And then as you can see, it becomes 5.99. And how about on the right side? X is approaching from the right side, which is x is greater than 2. So let us start from 2.025. So again, in assigning numbers here, you can write any number as long as it is very close to 2. Okay, so let this be your example, most commonly used. Yeah, so 2.025 here, 2.020, and so on. You're just going to list all of the assigned numbers. The same process, you're going to substitute 2.025 in the function that you have plus 4, and then it will be equal to 6.025. The same process that you are going to do for the remaining values. And as you can see, as it approaches to 2, it it is equal to 5.99. It is almost what? 6. Ayan. The same also with the other side. It is almost 6. 6.001 thousandths and then 5.999 thousandths. See? This is how you're going to find the limits. Okay. Therefore, the answer of the limit of the function x plus 4 as x approaches to 2 is equal to 6. Another example. This is evaluating limits again. So we are going to find the limit of function f of x is equal to x squared as x approaches to 1. Okay, so again, write the function next to the lim word and then x approaches to 1 is under lim. And then we are going to find the answer, which is what we are going to solve now. Okay, so we have 1. So to the left of 1 is less than 1. So we are going to have 0.980, 0.985, up to 0.999. Very, very close to 1. The same also here. We're going to start from 1.025 up to 1.001. Very close to 1 again. Then the same process, evaluate, substitute it, 0.980 squared. It becomes 0.9604. The same process. The answer is 0.9980. It is the same. So in this case, our limit is also equal to 1. The same process that you're going to do here. Okay. There are cases also that you are asked of the one-sided limit. There are no, let's say, no values that are no two values are approaching a certain limit or a certain c. So we only have one, either from the left or from the right. If it is from the left, then it has this sign here, c negative. If it is from the right, it has the sign here, c positive. And if does not have any sign at all, then you are going to solve for the two, of course, from the left and from the right. Okay, let us have example. This is what we call one-sided limits. Okay, this time we have a piecewise function. Okay, so we are asked to find the limit of the function t of x as x approaches 1 from the left, and then it is equal to 5. Ayan. Later on, we will know why it is equal to 5. Let us solve it first. Okay, so since we mentioned here that it is approaching from the left, therefore from the left this is negative, or let's say less than 1, because it is from the left. If it is from the right, then this is greater than 1. So since we have our function here, okay, but first let us have this assigning of numbers, the same assigning of numbers from 0.980 to 0.999, very close to 1. Okay, and then since we have our function here, 2x plus 3 comma x less than 1, and then x squared minus 4, if x is less than or equal to 1, then we are going to analyze. Since we have x is less than 1 because this is negative, then we are going to use this function here, 2x plus 3, or this expression here, 2x plus 3, since it has the condition x is less than 1. Okay, we cannot use this one because it is greater than or equal. So the same process again, substitute the assigned value 0.980 to the chosen expression aligned to this condition. 2 times 0.980, that is 3.980, or let's say 1.980 plus 3. Okay, and then that will be equal to 4.9604. 4. Again. 2 times 0.980, that is 1.9604 rather. Okay, not 1.980. That is 1.9604. and then plus 3, and then that becomes 4.9604. The same process, and then as you can see, it is approaching to 5. Therefore, the limit of the function is equal to 5. Okay? In short, of course, in short, you can only use this one. Okay? You can only use this very last, very close to 1, 0.999, and then substitute it here in our expression. Then you will have the answer of 5. But to better illustrate it to you, we use these functions here. Okay? So again, take note that limit of f of x is not f of c. Okay? It is not merely substituting. We need to follow the steps. Another example, we have the three expressions type of piecewise function. So using the function f of x is equal to 2 if x is greater than 1, 1 if x is equal to 1, negative x if x is less than 1, then we're going to evaluate the following limits. Or yes, we have limit of f of x, this function, if x is approaching 1 from the right. So this is greater 1. So we are going to find greater 1 here, which expression is greater than 1? This one, the first expression, 2. Okay, so since this is a constant function, regardless of what assigned numbers you have input here, then it is always equal to 2. No need of substituting if it is constant function. Another example is limit of f of x as x is approaching 1 from the left. From the left this time, this is less than. So we're going to use negative x. So substitute negative times 0.980, that is negative 0.980, and so on and so forth. Then you will have negative 1. Okay. Next, what if we have this one? Limit of f of x as it approaches to x, as x is approaching to 1. Okay, x is approaching to 1. In this case, the limit does not exist. Okay, the limit does not exist. In this case as well, f is f of 1. This is the same with evaluating functions. There are cases. In the next video, you will learn that there are also cases that it is just like you are evaluating a function in our limits. The work becomes faster. Okay, so f of 1 is equal to 1. That's it. Thank you so much, and kindly watch the next video.